folks, welcome to section 7.6. Now keep in mind this is out of a different book. This is going to be out of the intermediate algebra book. So you can see the page numbers are a little different than what we've been used to, and the problem numbers are way different. They don't reset in every section, they just keep on going. But at the end of this, we want to solve something called rational inequalities. And anytime you hear that word rational, inside of it is the word ratio. Right, so this is code for we're going to have some fractions. And anytime you introduce fractions, you got to be aware of a domain issue, right? So our little spidey senses go off. And we remember that our denominators can't be zero. Okay. They can be positive or negative, but they cannot be zero. We're not allowed to divide by zero in math. So we're going to solve what we call rational inequalities. You're going to have an inequality symbol, right? No equal sign, but either a greater than or equal to, less than or equal to. And you're going to have fractions in it, right? You're going to have a fraction with your variable. And you can see here, I have the variable in the denominator. Here it's numerator and denominator, right? Denominator. And we're really going to be wary of when those variables are in the denominator, because that's when we have to make sure our denominators are not zero. So I can give you anything like this, like 3 over 2x greater than 1. 1 is 2x over x minus 3 less than 4, so on and so forth. And we're gonna create what we call a sign pattern, and we're gonna solve these rational inequalities. And again, that's our end game here. Can I solve a rational inequality? So things that we wanna look out for when you realize you have a rational inequality, meaning you have a fraction, right? Variables at minimum in the denominator, right? Well, actually it could be either. It could be numerator or denominator. What you first want to take a look at is the number on the right side of the inequality. You want that to head to zero. So for example, if I gave you this inequality, the first thing you would do was subtract 1 from both sides and get common denominators on the left side. For this second inequality, I would subtract 4 from both sides and then get common denominators and simplify that expression on the left side, right? I'd subtract x from here, I'd subtract 3 over x from here. So that's your first pass, is do you have a 0 on one side of your inequality? And then pretty much your game plan is going to be setting your numerator denominator to 0 and creating sign patterns. So if we kind of think of this as steps, right? Get 0 on one side of the inequality. And if it comes that way, which maybe, oops, let me write inequality a little clearer, which you can kind of see here on example 1, right? I already have a 0 there, so I'm not going to have to worry about that, right? But then we're going to get 0 on the one side of the inequality. Simplify other side of inequality. Simplify other side of inequality, which usually means getting common denominators. Hold on, inequality. I can't spell inequality. Quality. Get common denominators, rationalize that fraction. Right, then you're going to hear me talk about setting your numerator and denominator to 0. And I'll talk about that a little bit more when we get to example 1, and then create a sign pattern. And if we're not sure what a sign pattern is, I'm also going to show you that in example 1. Okay? So let's take a look at this. So if I look at this inequality in example 1, just take note that I already have my 0 on the right side of the inequality, and I don't have to add or subtract anything here. It's not like I have 2 fractions that I need to subtract. This is already simplified. And of course it is. It's just example 1. I'm going to scooch this up a wee bit. All right. So the next thing I'm going to do, since I have a 0 here and this is simplified, let me set numerator and denominator to 0. And for right now, I really want to focus, just address the denominator being 0. You have a fraction. We know that we can't have a 0 in our denominator, so we definitely need to find that value of x that zeroes out our denominator, because this inequality, or excuse me, this rational expression is undefined when the denominator is 0. So let's go ahead, set numerator and denominator to 0. So I'm going to do x minus 1 is 0 and x plus 3 is 0. These are our first wave of like interesting points that we want to take a look at. So if I add 1 to both sides here, I'm going to get x equaling 1. And if I subtract 3 from both sides here, I'm going to get x equaling negative 3. Okay. So the next thing I'm going to do is create something called a sign pattern. And a sign pattern is like a smushed XY axis. All right, we're really just gonna graph the X axis, and I'm not gonna graph any heights. All right, I'm just gonna be on the lookout, and let me write this here. When we create a sine pattern, literally the word sine is in there. I'm really interested in when are things positive, when are things 0, and when are things negative. All right, so I really just want to pay attention to literally what are the signs? Are they positive, 0, or negative? And the reason I'm interested in that is because I want to figure out where things are greater than or equal to 0, for example, 1. So if I want to talk about when things are greater than 0, I'm going to look at where my rational expression is positive. If I want to think about where things are equal to 0, I'm going to look for where my rational function is 0. And then I'm going to rule out anything that's negative. So I'm going to scooch this up again, and we're going to create our first sine pattern. And when you go to create a sine pattern, again, you're making a smushed XY axis, and it really kind of looks like you're just making an X axis. But let me go ahead and draw the number line. Okay. There we go. All right. So I'm going to label this. You can think of this as your x's, right, on your x-axis. And you might be tempted to write y here, because usually we do x, y, or maybe x, f of x. But go ahead and write the actual rational expression that you're interested in. All right. So we've got arrows at the end of this, right? Negative infinity all the way on the left side, positive infinity all the way on the right side. And these are my interesting points so far. So I'm going to say something interesting is happening when x is -3 and when x is 1. So that's how you read this. These numbers down here are x values. These are going to be signs, right? I'm either going to put plus, minus, or negative, excuse me, plus, minus, or 0 up here for this rational expression. All right, so -3. When x was -3, if I plug -3 into this expression, right, I'm going to get a 0 on the denominator. I would have -3 plus 3, which would be 0. Coincidentally, I'd have -4 up top, but really the important part is that I'd be dividing by 0. So this value does not exist, right? So when x is -3, down here, if x is -3, then x minus 1 over x plus 3 does not exist. That's how you start to read this, okay? When x is 1, all right, if x is 1, 1 minus 1 in that numerator is 0. 1 plus 3 in that denominator is 4. 0 over 4 is 0. All right, so I've found where my rational expression doesn't exist and where it has a 0. And then everything else has got to either be positive or negative, because if there was another 0, I would have found it algebraically. So I'm going to erase my little 0 over 4. And how we start to flesh out this sine pattern is think you've broken up this x-axis that's from negative infinity to infinity into 3 parts. You've broken it up from negative infinity to -3, -3 to 1, and then 1 to infinity. So we pick test points at this point, all right? And what I mean by that is, let's look at this right interval from 1 to infinity. Pick a test point. I'm just going to pick 7 because I feel like it. Okay. And I'll eventually erase this little guy, but pick a test point in here, any number larger than 1. So I'll try 7. If I plug 7 in, I have 7 minus 1 on the numerator, which is 6. 7 plus 3 on the denominator, which is 10. And I don't even care about the number, because again, this is a smushed y-axis. We don't care about the height. We literally just care, was that number positive or negative? And a positive over a positive is a positive, okay? So then we move to our next interval, our middle interval. Pick any x value. Start with the x's, any x value between -3 and 1. I typically like to pick 0 because it's relatively easy to plug in. So again, when x is 0, what is this rational expression? Let's see. If I plug 0 minus 1 in here, I'm going to have a negative on the numerator. 0 plus 3 on the denominator, positive. And a negative over a positive is ultimately negative. Right? So I'm starting even to ignore the values. I just want to look at the signs, right? That's why we call this a sine pattern. Right? What's the pattern? So I went from negative to positive as I move left to right here. Okay, now pick something on the left side of -3. Just for simplicity's sake, actually, you know what? No, I'll just pick -10. It doesn't matter what number. I could have picked -10. I could have picked -100. And let's collect positives and negatives, right? So again, when x is -10, right? So negative 10 minus 1 would be negative. Negative 10 plus 3 would also be negative, and a negative in ratio to a negative is ultimately positive, okay? So let me clean this sign pattern up. I tend to not actually write my test points. And when you get more experienced with this, you probably won't even write the little test point values. You don't have to. But this is only example 1, so we're starting. Okay. So my function went positive, then it didn't exist, then negative, then 0, then positive. And if I go back to my original inequality, now that I've made this sign pattern, this says greater than or equal to 0. So I want to collect all the positives and all the zeros, right? Greater than 0 is a positive, equal to 0 is a 0. So if I look at this, I want to collect this positive, I want to collect this 0, and I want to collect this positive. And how we write up our answers is we want to write them up in terms of x. So I want this interval, right? And then I want this interval. That is where this rational inequality is greater than 0 or equal to 0. And I want to write that up. So what I'm going to say here is x can be anything. That's what that little epsilon means. In this first interval, we're always going to go left to right, so low to high. We're going to go negative infinity to negative 3 with the parentheses. And the reason I'm going to use a parentheses, right, because you might be thinking, well, Miss Brea, don't you want to use a bracket? I know this says greater than or equal to, and we usually use brackets, but this value does not exist. I cannot put a bracket here because negative 3 is not part of the domain, right? We have that domain issue because we have a fraction. And then we can counter that, right? It's the opposite here. Because 1 is a 0, and I want where this is greater than or equal to 0, I am going to put the bracket around 1, and it's going to go all the way to infinity. So again, because this said greater than or equal to 0, I'm going to be using brackets. But what kind of overrides that is that this was a vertical asymptote, so it switches back to a parentheses. All right, thanks so much. Bye.